Let's take a look at a integration by parts problem with a definite integral. So first of all, we need to choose u. U should be chosen according to this priority list in general. Remember, it's not always true. There are exceptions, but in most cases, it's going to work out. So we can see right here, there's a logarithmic term. So that's going to be our u in this problem. So I'm going to move over here and write let u equal natural log of t. So my du is equal to 1 over t dt. And my dv would be everything else, t cubed dt. And so my v would be t to the 4th over 4. Okay, so let's go ahead and plug that into our formula. So I need u times v right here. And we're going to need to evaluate that at 1 and 2, minus our integral of v du. So here's our v, and here's our du. So it looks like we're going to cancel 1 power of t right there. So we'll have 1/4 t cubed dt. And again, that integral is going from 1 to 2. Let's just go ahead and substitute in our terms here. So I'll have 2 to the 4th over 4 natural log of 2 minus 0, because if I plug in natural log of, if I plug 1 in, natural log of 1 is 0, so there's 0 there. And then for this term right here, this is just a normal polynomial, so we'll use our power rule. So we're going to go up to t to the 4th power and divide by that. So we'll have t to the 4th over 16, and that's going to need to be evaluated between 1 and 2. Notice how my minus sign stayed outside the parentheses because, this whole integral right here is what got evaluated as this. So after I do this, I will need to, after I evaluate this, I will need to multiply it by negative sign. Okay, so let's go ahead and do that evaluation. 4 is 2 to the 4th, so I mean, I'll do that, and of course that'll be 4 in the end. Also right here, 2 to the 4th over 16. Let's think of 16 as 2 to the 4th as well. And minus, so I'm still in here. This minus sign is still out here. What I get when I plug in 1. Okay. So it looks like right here, I could have canceled those and left me with a 1, but it's probably easier if I just do 16 minus 1 is equal to 15. So we end up with 4 natural log of 2 minus 15/16. Okay. Next, let's do another integration by parts problem. One which is not a definite integral, but may also be interesting. This is another standard type of problem that integration by parts is very good for. Polynomial multiplied by something. Polynomial multiplied by logarithmic, polynomial multiplied by any of these things, really. Okay, so we're going to choose u according to our priority list. So we have in this, I see an algebraic, that's a polynomial, and a trigonometric term. And since algebraic comes before that, that's what we're going to use as our u. So that's our t squared. Du will be 2t. dv will be everything else, sine 2t dt. And v will be antiderivative of that. So this would actually be a good step for, if someone were critiquing my work. There's a lot of non-trivial calculation that goes into this one right here. We can check it now that I've written it down just by looking at it. what do you get if you take the derivative of cosine? Minus sine, so the minus cancels out, and we've got the sine. And then by the chain rule, you take the derivative of what's inside, so the 2 comes out and cancels out. So this is correct, but there would be some work there using, for instance, u substitution to figure that out. So let's go ahead and substitute that in. We're using the same formula, just without the bounds here. Okay, so it will be u times v, this by this, so minus 1/2 t squared cosine 2t minus the integral of v du. Okay, now since there's a minus sign right here, I can just move that out as I'm doing this substitution. Remember, I'm just substituting in here, so there's going to be a v and du. So that means there's going to be a negative sign and another negative sign out here. Together they just cancel out and do positive. So I'm doing a little simplification on the fly here. And then we'll have this times this. Negative sign's already been taken care of. So 2 times a 1/2 also cancels out. So I'm left with t cosine 2t dt. Okay, a little bit of algebra there. Again, might be good stuff to include in a critique where this like a discussion board post. Anyway, let's take a look at this new integral. It's much like the original integral, except that the degree of our polynomial term has dropped by 1. So it looks like if we do integration by parts one more time, we'll be home free. So again, we go through our priority list. U will be our polynomial algebraic term, and dv will be everything else. So u now is t. My dv will be cosine 2t dt. Okay, here's my du. And my v gets worked out in a similar way to this one. I'm going to need a 1/2 for compensate for that too, and a sine 2t. Okay. So now into this term, we substitute our result of our integration by parts formula. Okay. Let's see if I can leave that at the top of the screen there. So I'll copy this first bit down. And then, just to be safe, since I'm doing a substitution here, substituting this formula in for this integral, I'm going to put it in parentheses. Always a good practice. So uv minus the integral of v du. And this time it looks like the negative sign from our formula is going to stay there. It didn't cancel like last time with this guy. Also, the 1/2 won't cancel. Okay, so there's our v du. And we are just about done because this integral is a easy Calc 1 u substitution, u equal to 2t. That's actually what we've been doing the entire time here for each of these steps right here. So I'm not going to pay too much attention to that right now. I'm just going to jump to the end again. You should consider filling in those details on your own, like as if you were going to do a critique. So I'm going to need another factor of a 1/2 to cancel the 2 that comes out. And I'm going to need a cosine. I've already got a minus sign here, so it looks like we're positive. 1/4 cosine 2t and plus a c. Okay. So remember, we've got some stuff going on behind the scenes here. We've got a u substitution, u equals 2t there, and in all of these, when I'm going from dv to v, I'm using a u substitution of u equals 2t. U is probably a bad name here for your substitution where you're actually doing this, because there's another u in play over here. You might also ask, well, isn't this bad practice to have a u here and a u here? And in general, yes, you're right. However, notice how this stuff over on the side never actually makes it into my problem. So in other words, even though I'm talking about u over here, we don't ever see a u over here. So the reason for that is because this u and this du are different from the u substitution type of u. U substitution actually changes your variables into u's in your problem. This is not quite a substitution. It's simply a way of explaining to the reader how this theorem, the integration by parts theorem, is applied to this problem. So I'm saying right here, when I say let, I'm actually saying, let's use integration by parts theorem, where in the statement of the theorem, the u will be my t squared in this problem, the du will be the 2t, and so forth.